All right, so it is Analytical April. Following my trend of waiting until the last moment to get in and claim that I'm keeping up with these Exercism 12 and 23 challenge, but we're going to quickly try and do a few Julia exercises to get the badge. So I already actually started this. Scroll down here. I did the Hello World and 2 other exercises, so I need to do 3 more to get the badge. Kind of did them out of order. There wasn't a theme for January, but I was working on closure. The theme for February was Functional February, and that was supposed to be OCaml, but I didn't finish all 5 of them. I finished 4 of them. But conveniently, I had finished some closure exercises in February, so it gave me the badge for Functional February. And then March was Mechanical March, so that's where Russ came in. So Russ is supposed to be over here, and then Julia for Analytical April. So anyway, this is what I did yesterday. I kind of like solving. There's this idea of using katas, I think. Katas? I don't know how it's pronounced. I think it's katas, where you have like the same exercise that you replicate across different languages, and it's kind of neat doing exercism where you can solve more or less the same set of exercises in different languages and get a feel for, instead of focusing on solving the problem, which is a good thing to focus on, but focusing on how to do it in that language after already knowing how to solve the problem itself. So you're focusing more on learning the language than on solving the problem, which is neat. But there is something to be said about knowing how to do it well in that language. And I've been liking OCaml. I gave OCaml another shot a few weeks ago. Tried to live stream it, but ended up not recording the audio. It ended up being a lot better experience than my first experience with OCaml. So things were working conveniently. I even had Copilot suggesting me valid code and all that. And I like how this turned out here. I'm pretty happy with it. And it's similar to how I had the Rust code as well. Let me open that up. Code, Rust raindrops, I think. I think I did more or less the same thing for, I think it's in lib or something like that. Source lib, yeah, there it is. Oh, okay, it is a little different in Rust. So in Rust, currying or partial application is kind of an anti-pattern. It's not very easy to return a function from a function. You can do it, but you need to do something like called a box or something like that. Because of something, I think it's related to lifetime constraint, I think is what it is. So, yeah, it didn't quite work out there. I think the first time I solved this exercise was actually in Closure. Let's take a look at how I did in Closure. So basically, this is on FizzBuzz. That's what it is. So, source, raindrops, Closure. Here we go. Okay, I got a little fancy with metaprogramming a little bit in Closure and made this thing called def sound. But it more or less works the same way, and I liked how I iterated over the sounds, and so I tried to keep that same theme as I saw the rest of them. I'm still iterating over these sounds as well. And I watched the video for how to do this in R, and they had a very nice, clean, like 2-line implementation of this. But anyway, so far, OCaml is my favorite of this and how to solve this. I think it's pretty clean. Anyway, tried to do more or less the same thing in Julia. And Julia does have the ability to return functions. So they are first-class functions, but I think, now this is supposed to be the pro of Julia, is what's called, why can't I remember anymore? Multiple dispatch, that's what it's called. So basically it's the idea that a function is really defined by its name, its arity, how many arguments it has, but also the type of all of the arguments. And actually that's not, yeah, I guess that's true. They kind of call them methods. So they're like in object-oriented programming, right? You would have a method on an object, and it would the behavior of that method, of course, depends on the object that it belongs to. But the idea is that you could have these things called methods that don't really belong to an object. They kind of belong to all the objects that are needed as its arguments, as its parameters. So anyway, because of that, there were some issues with the type inference, I believe, of the anonymous function that was passing out. And I actually had to explicitly tell the type here so that when it did this mapping, it could do it. Also, piping is weird. I was playing around with this. I'm not sure this is true or not, but it looks like you have to put the pipe on the previous line instead of on the current line. And then there's also something about, oh yeah, that's what it is. So piping is really nice because it takes the thing and passes it to the next argument, next function, right? But it only really works cleanly with Julia if the function only expects one argument. So this is where, of course, auto currying in OCaml is really nice. I can just not give it all the arguments, and then it will pipe it as the last argument. And I say last argument, it really is because it's curried. Every single time you call a function with fewer arguments than it needs, it returns back a function expecting the next arguments. And in that case, if you provided all but one, it is now a function expecting exactly one argument. And so, that discussion about whether or not things get piped in at the beginning or at the end, it just falls out. There's no such thing as beginning or end. There's only one place it could go because every single function only takes one argument. Anyway, because of that, piping is not great, and I actually have to manually wrap everything in a lambda. So, first thing I'm going to do is actually take a look at maybe to see if there's some more idiomatic ways of doing that in Julia. So let's take a look at some of the solutions in the community for that exercise. And then hopefully they'll give me a better idea, because I think the next exercise I plan on doing will also be related to some Boolean and pattern matching. There's no pattern matching in Julia. There's also no switch statement. So if you want to do multiple if-elses, you just have to do multiple if-elses. So that's kind of annoying. There's a Turner expression. So that's my iteration. Let's see some of the community solutions here. Okay, so they're doing the normal mod equals just inline there. Okay, interesting. So they're mutating the string, setting the string to empty, and then they're adding on to the string with this star equals. Okay, good to know. Here we go. Here's a map fold. Look at that. Base.mapFold factor. There we go. 3 playing. Okay, similar to mine. Factor number. First factor. First. Okay, first takes it out of the tuple, I suppose. Is equal to 0. Last factor. Okay. Okay, so they're just inlining. This is essentially my sound function in here, just inlined. And I did. Julia does have destructuring, so that's what I did there. So this function, this could be improved by destructuring in. Let me think about this. First factor Yeah, okay, so they're calling this whole pair factor. They could just destructure in there. So far I've not seen anything super dramatically more reliable here. Okay, here we go. That's looking good. S is equal to, not sure why they like using really short names in Julia. Grab the second one, filter, okay, on the first one, okay. Pipe to join, okay. Oh, okay, so I guess I could simplify my code here. Let's try that. I think I can just pipe to join because I don't care about the delimiter, perhaps? Is that what that is? It's not yelling at me. Let's do Julia run tests. Oh, I forgot to mention how I have my setup here. It was relatively no run tests.jl. Julia run tests. It was relatively easy to get Julia up and running. I used ASDF and the plugin for that. I'm trying to be more consistent in how I install things here, so I'm going to try and use ASDF to set things up in the future. The Julia plugin is working fine for VS Code. It's got some, completions and things like that. So, all right, so that did simplify things, and it did all the tests did pass. So I'll submit that as well. Can I simplify this one any more better? I don't think I can do that with map here because I need to pass this explicitly to the second argument there. I did think map is going to map over this whole thing. It's going to take each one. Okay, I see. I'm passing this whole thing is going to X. Then, yeah, okay. I was thinking I could eliminate my helper function thing. Anyway, that's good enough. So anything I can do to improve this one, I'm just saying if X is equal to empty string, then stringify the number, otherwise return X. No, I don't think I can really simplify that too much more. Okay, we'll submit that as well. Anyway, I'm not seeing a whole lot of other, let's take a look at this one here. Pairs drop for factor, drop in factor range drop pairs if number equals factor. Ooh, okay. I like this. This is good. This is good. So, I think what we have here is a for comprehension. We're saying drops is drop for factor drop in factor range drop pairs if number, okay, so if it's a factor of that factor, then take the string. Oh, I like that. They just inline the join right there. Yeah. Okay. This is so far the best I've seen. I'm going to give them a star for that. This one, a star. There we go. This one so far is the best. For comprehension, I think is better there than the map. All right. So now that we know that, let's move on to another exercise. Let's go to see what some exercises they recommend here. I just want to do a couple easy ones to kind of get the badge, and then hopefully I'll come back and give Julia another shot on some of the things that does a lot better at, and get a hang of that multiple dispatch thing, because that's really its main selling point. Pangram. I kind of like Pangram. Pangram and Bob, I think, are the ones that I enjoy doing. All right, let's try Pangram. Oops. That's not where I wanted that. Save. Okay. Pangram and readme. So basically, we need to check to see if the input is a pangram. Basically, it contains every letter in the alphabet, case insensitive. All right, so this is what Copilot says I should do. Let's take a look at it. Input is equal to lowercase the input. Okay, good. For character in the range from A to Z, if the input contains that, return. If it doesn't contain it, then return false. Oh, yeah. Excellent. I presume Julia has early return, but it's also more of an expression based, so I think I can leave off that return there. I think let's just single line this for C and AZ. If not contains I wonder if there's a double and, if that's a thing. False. No, I think I have to actually say return false. Let's just run it as is and see what it does. But that solution looks correct. I think I did something a little fancier in some of the other solutions I did, but let's give this a try. So Julia run tests.jl. Yeah, all passed. Okay. Good enough. Is there anything else we can do to improve this? We don't necessarily need to assign that to something else. This is more just cold golf than anything else. No, we do need to assign it. Okay. Iterating over A to Z, checking to see. Okay, I know what I did to solve this in like a Rust or something like that. Let me open that up so we can see. I was trying to be a little bit more performant in Rust to see if I, because I mean that's what it's for, right? To write performant code. So what I did in Rust is this is called Pangram. Source lib. Here it is. It's pretty straightforward here as well. So I actually iterated, instead of on the list of, this will go over the list of numbers, sorry, the characters in the alphabet, the letters in the alphabet once, but it could potentially go over the entire string each time. So that would be 26 times your input. And so let's say your input's like, 200 characters long, that'd be 26 times 2, right? That's how many times it would essentially go over it. I decided to go over the sentence only one time. So let's say you had 200. It would only go, at the most, 200. Actually, in this case, I don't think I optimized it to stop when it got all of them. But so essentially, I kept inserting all the letters. Let's see, hash set new. I use a set. I inserted into the set if it was an ASCII character, and then basically said, okay, once. Sorry, I lowercased it. I checked to see if it's alphabetic, lowercased it, and then counted up to see if I have all 26 letters. So this is guaranteed to only go over the string one time. Do I really care about that optimization here? I don't know. But let's do it anyway. Let's keep that open as a reference here, and actually maybe copy over the code so we can see as a reference here. Okay, so this is how we do it there. So the first thing we need to do is create a set. Does Julia have sets? I don't know. Create a new set. All right. I don't know if that's correct or not, but we're going to roll with it. And then we say 4-letter and sentence chars. For cin input. Haha, look at that. If is ASCII character and is alpha character, push letters lowercase c. End. And then return length of letters is equal to 26. Okay. No idea if that will work or not. But GitHub Copilot is trying to help us out. There's no red squigglies, so that's a good thing. Julia run tests. Empty sentence passed. Okay. So some passed here. Test through an exception. Is alpha is not defined. Okay. So it just made up code that's not valid. Let's check to see. Let me just first do this thing where I'm just going to print the character, and I'm going to, so there is a REPL here, but I haven't figured out how to use it very effectively. So we're going to do that and just call the function itself. Okay, well, it printed all the characters, apparently, but not... Is there a string interpolation? Let me guess what it would look like. Is it this? I don't know. Print character plus new line. Sure. See what it suggests for us. Print. Nope. Okay, well, we'll try that. See what that does. Okay. All right, let's pull out a reference here. Julia string interpolation. Looks like it's going to be similar to this, but instead of curly's, it's actually parentheses. All right, so it is actually iterating correctly over that. So now what we need to focus on is a way to check to see if it is an ASCII character. I think what we can do is we can just say lowercase char. I like being a little bit more verbose with the names here. Lowercase char is equal to lowercase char, and then we'll just say if lowercase char in AZ push letters lowercase char. Okay. Let's try running the tests. All passed. Excellent. So we've implemented more or less the same Rust code in Julia, and yeah, not too painless. Painful, I suppose. Not painless. Do exercism, submit, and move on to maybe one more. I don't know, I might call it a day because it's getting a little late over here, but definitely hitting a flow a little bit better here. Maybe we'll try one more. Maybe we'll do Bob. Bob is all about string manipulation. And I like to try and do these things without regex if I can. Okay. Let's open up my OCaml implementation and just more or less copy that. So OCaml Bob ML. Okay, so we have an is question suffix and then an is yell. Got it. Now there's no nice pattern matching in Julia, so we're just going to have to start off with the whole if-else structure. If is empty, sure, we can do that. Return, fine, that be that way. I wonder if it, I don't know. I wonder if I can leave off that return or not. Is it else if? Else if is okay. If it's empty, fine, be that way. If it's a question and it's a yell, calm down, I know what I'm doing. If it's just a question, say sure. If it's a yell, say whoa, chill out. Else, say return whatever. Return whoa, chill out. Okay. I don't think there's a better way. I'm not saying this is an amazing way. I'm saying I don't think there's a better way of doing a bunch of logic like that. There's no like match or switch or anything like that in Julia, to my knowledge. But we'll take a look at some community solutions afterwards. Okay, so is question is simply does it end with a question mark? And I've realized that we also want to do say function is question stimulus. Sure. We'll continue the trend and return ends with. Okay. No idea if ends with is an actual thing or not. We also want to trim it first, so we're just going to say stimulus is equal to strip stimulus. Okay. Let's see if any tests pass. Actually, none of them will because I haven't defined the is yell function. So let's return that. So function is yell stimulus. Let's see what it did. Return stimulus is equal to uppercase stimulus, and stimulus is not equal to lowercase stimulus. That's almost true. We also want to make sure that upper string, uppercase ASCII string in is letter character in sequence filter is letter. So basically we want to filter out all the things that are not letters and check to see if there is still anything left in the string. Let's see if anything passes when we do this now. Okay, some are passing. I'm not seeing any I'm not seeing any errors of code being wrong or something like that. So it's just a logical error, I think, at this point. Okay, so is and a thing? Nope. And stimulus. What's the best way of filtering things in Julia? Julia filter string. Common operations. Find first, find last, find next, find occurs in, repeat, join, non-standard, length, code units, code unit, this index, next index, regular expressions. Okay, I mean, we could use a regular expression if we wanted to. Well, we had that range thing that we used in the other one, right? I just want to filter. This looks like a data frames thing. Let's go to the REPL real quick here. Say Julia, and we'll do filter. Filter takes a function and then one of these things. Tuple array, abstract dictionary, bit array, abstract array, abstract string. Okay. So let's try this. We'll say x in a z a string ABC 1 2 3. Ha ha ha. Okay, let's do that. Is there like a count if maybe? Count t. There's a f there, function. Julia, countif would be kind of nice. Countif. If not, we'll just count it afterwards. That's fine. Count is an inbuilt function, Julia, which is used to count the number of elements in the array for which the predicate returns true. And if p is a matrix, it counts the number of true elements in the given collection of Boolean values. Interesting. So it is actually that. So we should be able to do the same thing where we say x in a z, and then give it ABC 1 2 3 4 3. Look at that. Okay, so let's do that. Copy our code. Stimulus, and we'll say is greater than 0. And I think that should be it. I think I have to exit, and Julia, run tests. Okay, everything failed. What's going on? No method matching and, oh, is it double and or something? Double and. It is double and. Whoa. Interesting. Okay, so when let's say I were to comment out this bit. We have the majority of the tests passing. Questions. These two are the ones that are failing on it. Now we do have, are we, at this point, stimulus, okay, so stimulus may be, what should be happening here? This is saying that it's a question. Should that be responding with a question or with, I don't know. It's saying, calm down, I know what I'm doing. If it's a question and it's a yell. So this is saying currently, it is a question and it's a yell because it thinks that it is a yell, but it's not a yell because, okay. So we want to make sure that the count of things in that range is greater than, yeah, okay. So maybe what we can do is we assign uppercase stimulus to uppercase stimulus. Make sure that this is uppercase stimulus and has uppercase stimulus over here as well. Okay, I think that should do the trick. Whoa. Isn't that weird that it at first looked like it passed all of them? And then, is that doing that for this one? No, it's not. And then it gives this whole thing, and it goes all the way down to the table here. It says that all of them failed. What's going on with that? They're all saying, whoa, chill out. No, I don't know. It's actually giving like the same test every single time. Is it passing or is it failing? I can't quite tell. Because we're pretty close with this, right? We're pretty close. But then when we add that last bit that counts and make sure it's greater than 0, I'm just going to do print. I want to count the things that are greater than that, and I also want to print the stimulus along with it to see what's going on. Does this cryogenic chamber make me look fat? It says 0. Aha! Okay, I know what's going on. Because I uppercased it, this has to be A to Z uppercase. Alright, that I think should do it. That's a pass. They're all passing. Excellent. Okay, can get rid of all this now. Okay. Let's get rid of all my other code here and should be done. Should all pass. All right, and I'm gonna call it here now. Before I do that, let me just see how other people did on this Bob exercise. Mark is complete. Submit it for review. And we'll take a look at what other people did. The most starred one is this one with 30 stars. Okay, so they didn't abstract the questions, but they just said any is uppercase S. Yelling, string is equal to uppercase, and any is uppercase. Oh, interesting. They're just saying, are there any uppercase letters? So I guess there's an inbuilt thing called is uppercase, and just saying, are there any in there? Question ends with nice. Well, is that what I'm using? It is, okay. I didn't look it up, so it's just built into is empty, stripping it. Yep, okay. It's all the same. It's all the same. And that's the most starred one. All right. I think I only have one more to get the badge, but I'm gonna do that another day and go to bed. So